Hello, everybody. I am Irina Rudneva. I am civil engineering lecturer, PhD, and associate professor. First of all, I would like to tell about myself a little. I am from Ukraine. And now I live in Kiev. Kiev is the capital of Ukraine. Now I am on the position of Associate Professor at Civil Engineering Department of Kiev National University of Construction and Architecture. It's a major construction university in Ukraine. Kiev is the historical center of Kievan Rus. There are many buildings and monuments of architectural heritage. About my academic experience. Now I am associate professor in Kiev National University, and before I was associate professor of the civil engineering department in Donbass National Academy of Civil Engineering and Architecture, where I have worked during 12 years, and where I was appropriate a PhD degree of specialty engineering structures, building and construction in 2006. Also, I was lecturer at Hubei Engineering University in Saogan City, and also from March 2020, I am lecturer of Beijing International Education Institute. Also, I have postdoc mobility at University of Novgorod. My office was in Venice, and I collaborate with University of Venice, Istituto Universitario di Architettura di Venezia. It was very interesting and useful experience. About my teaching experience. I given a lecture on strengths of materials, engineering and building mechanics, material and environmental science, building construction and construction technologies, site management and safety, structural analysis, Eurocodes, and construction project management, etc. Also, I am founder and chief project engineer at the project company SVK. I am expert in survey and design of civil and industrial building, and I am project manager of many projects. Little building, large building, etc. The course that I begin to lecture for you today is called Material and Environmental Science, Module 0, Lesson 1, Introduction. So, what is about? There are many types of building materials used in construction, such as concrete, steel, wood, and masonry. Each material has different properties such as weight, strength, durability, and cost, which makes it suitable for certain types of applications. The choice of materials for construction is based on cost and effectiveness to resisting the loads and stresses acting on the structure. As a structural engineer, you will work with your clients and you will decide on the type of materials used in each project depending on the size and use of the building. The manufacturing of building materials is a well-established and standardized industry capable of providing a reliable supply of high-quality materials for our structures. The production of structural-grade building materials is subject to quality control procedures that involve inspection and testing according to national standards and scientific testing methods. Part of the structural engineer's responsibilities is to prepare the project specifications, including all building materials and applicable standards and provision to comply with. This is a crucial part of any project to specify the quality and property of materials to be used. And building materials can generally be divided into two categories. Natural building materials such as stone and wood, and man-made building materials such as concrete and steel. Both categories usually require a certain level of preparation or treatment before the use in a structural application. The purpose of this model is to introduce the use of sustainable building materials, exploring the importance of insulating materials used in buildings and their effect on heat losses in modern buildings. The model will allow the student to identify those materials that have a minimum impact on the environment and how the durability of those materials may be improved. Also, this model will give opportunity for you to consider the scientific principles that affect human comfort in the enclosed environment. Learning outcomes. On satisfactory completion of this module, students are expected to be able to identify the main types of construction materials, their properties, and how and why materials fail in use. Describe principles involved in the selection of materials in construction and the issues affecting their durability and sustainability. Discuss insulation materials and their effect on heat loss from buildings. Evaluate the scientific principles that affect human comfort in the enclosed environment. Module content. Construction materials and their properties. Include construction materials such as plastic, wood, steel, stainless steel, concrete. For example, concrete is a composite material made from mixing cement and aggregates such as sand and crushed stone and water. Steel is one of the strongest building materials available with excellent strength capacity in both tension and compression because of its high strength to weight ratio. Composite materials include steel wood, wood concrete, steel and concrete. The next materials have physical, thermal and chemical properties such as expansion, contraction, chemical, electrochemical, freeze, so action. The next one, material degradation, rust, cracking, creep of materials, resistance to moisture, floors, walls, roofs, etc. And of course, durability of construction materials. Properties of building materials. What is this? For a material to be considered as building material, it should have required engineering properties suitable for construction works. These properties of building materials are responsible for its quality and capacity and helps to decide application of these materials. Such properties of building materials are categorized as physical properties, mechanical properties, chemical properties, electrical properties, magnetic properties, thermal properties. Also very important are physical properties of building materials. These are the properties required to estimate the quality and condition of the material without any external force. And the physical properties of engineering materials are density, durability, density index, fire resistance, also frost resistance, specific gravity, water permeability, hygroscopicity, refractoriness, specific gravity, etc. So many properties of construction materials important for application materials for some construction that you used. Durability of building materials, very important because the property of a material to withstand against the combined action of atmospheric and other factors is known as durability of material. If the material is more durable, it will be useful for longer life. And maintenance cost of material is dependent of durability. Density of building material. This is a ratio of mass of the material to its volume in homogeneous state. The next part of model content is sustainability and embodied energy that include embodied energy, whole life costing and life cycle analysis, service requirements of materials, environmental impact, and carbon and energy targets. All human activities affect the environment. Some are less impactful, some much more. According to the United Nations Environment Programme, the construction sector is responsible for up to 30% of all greenhouse gas emissions. Activities such as mining, processing, transportations, industrial operations, and the combination of chemical products result in the release of gases such as CO2, etc., water vapor, halocarbons, etc. When these gases are released into the atmosphere, they absorb a portion of the sun's rays and redistribute them in the form of radiation and in the atmosphere, warming our planet. So today this layer has become too thick that mankind is beginning to experience severe consequences such as desertification, ice melting, water scarcity, and the intensification of storms, floods, hurricanes, which has modified ecosystem and reduced biodiversity. The next part, insulation and sustainable construction, that include building regulation requirements, thermal resistance, and conductivity, insulation materials, adopting building for climate change. Insulation is a key component of sustainable building design. A well-insulated home reduces energy bills by keeping warm in the winter and cool in the summer. And this in turn cuts down carbon emissions linked to global climate change. In terms of energy efficiency, investing in high levels of insulation materials for your home is more cost effective than investing in expensive heating technologies. it's worth taking the time to source the right materials in the context of wall building design. Insulating materials are used in roofs, walls, and floors. Solid wall structure such as stone, cob, and adobe cannot be insulated, but they have good thermal mass to compensate. Insulating material work by resisting heat flow, measured by an air value. The higher the air value, the greater the insulation. This air value varies according to material type, density, and thickness, and is affected by thermal breathing, unwanted heat flow that occurs at joist studs and rafter beams. So conventional insulation materials are made from petrochemical and include fiberglass, mineral wool, polystyrene, polyurethane foam, and multi-folds. These materials are widely used because not only are they inexpensive to buy and install, but there is an assumption from the building industry that their performance ability is higher than the natural alternative. And next part of module content will be a human comfort and psychometry. That include introduction to thermal comfort standards, temperature and humidity, lighting and glare, acoustics and vibration, irritating, harmful vapors and other substances. So what is human comfort condition? Human thermal comfort is defined as a condition of mind which expresses satisfaction with the surrounding environment. High temperatures and humidity provide discomfort. Also, thermal radiation provides discomfort, stress, and discomfort sensations, and sometimes heat stress, including reducing the body's ability to cool itself. So it can be solar load, room AC, movable window blind, window that not comfortable, convective exchange with environment. You can see here. So what is the psychrometry? Psychrometry. Psychrometrics and hydrometry are names for the field of engineering concerned with the physical and thermodynamic properties of gas-vapor mixture. And the term comes from the Greek psychron, meaning cold, and metron, meaning means of measurement.